Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's Security Boulevard webinar. Today we have a container live hack, managing container vulnerabilities in Amazon ECR and Amazon EKS. I'm joined today by Clinton Herget, who's a Principal Solutions Engineer at Snyk, and Raj Jarapotula, who's a Senior Partner Solutions Architect with AWS. Before we get started, I need to go over some housekeeping items with you. Just a reminder that this webinar is being recorded, so if you miss any or all of it or just want to go back and watch it again, you'll be able to do so. We will send an email with instructions for how to access the webinar on demand, or you can visit us at securityboulevard.com/webinars, and it will be there also. We are taking questions from the audience, so make sure if you have any questions during the webinar, you can submit them using the Q&A tab on your console. We will try and get to as many as possible at the end of the broadcast. If we don't get to your question, though, rest assured we will send them over to our panelists today, and they will be able to follow up with you after. And finally, we're doing a drawing at the end for 4 $25 Amazon gift cards, so stick around to see if you are a winner. And with that, I'm going to hand it off to Raj to get us started. I'm going to turn my camera off and mute myself and let you take it away. Thank you so much.
Thank you very much. Hello, everyone. My name is Shashiraj Jaripopula. I'm Senior Partner Solutions Architect at AWS based in San Francisco. I work with various independent software vendors, AWS partners, specializing in cloud management tools and DevOps segments to develop joint solutions and accelerate cloud adoption on AWS. Today, I will talk about containers at AWS and the core container technologies available at AWS. So one of the most common requests we hear from customers is, help me decide which container service to use. So AWS customers have a choice of fully managed container services, including Amazon Elastic Container Service, ECS, and Amazon Elastic Kubernetes Service, EKS. Both services support a broad array of compute options, have deep integrations with other AWS services, and provide the global scale and reliability you would come to expect from AWS. So far, how are they different? How ECS is different from EKS? So let's talk about it and decide which one to choose. Let's start with the first one, ECS. As the heading says, powerful simplicity. So what customers tell us that they love most about Amazon ECS is the simplicity it provides. Amazon ECS delivers an AWS opinionated solution for running containers at scale. It reduces the time it takes customers to build, deploy, or migrate their containerized applications successfully. Amazon ECS powers a growing number of popular AWS services, trusted by hundreds of thousands of customers. Customers adopting containers at scale, seeking powerful simplicity. As I said, the keyword is simplicity. Should start with Amazon ECS. Next, we talk about EKS. So as the heading says, open flexibility. So team chooses Kubernetes for its vibrant ecosystems and community, consistent open source APIs, and broad flexibility. They rely on Amazon EKS to handle the undifferentiated heavy lifting of security and operating Kubernetes at scale. Amazon EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. EKS is optimized for customers building highly available shared services platforms based on open source technologies. Customers adopting Kubernetes that want open flexibility should start with Amazon EKS. So basically, if you are using EKS, if you're using Kubernetes already, then migrating to EKS is going to be very easy for you. So the keyword, again, flexibility, right? How do you want to reuse something that's already running on-premise, or you already have clusters running in different clouds? So then the keyword is EKS. So now let's come to something new. So right now it's in preview. So most of the time, customers talk to us was how to use ECS for applications portfolios that span AWS, on-premises, and other customer managed infrastructure. So we have something coming up in 2021. Right now it's in preview. There are website, I will give you URLs where you can go and give a try with it under preview. There are some terms and conditions. So do go and try with it. And I will talk more about what you can achieve with the Amazon ECS Anywhere. Amazon ECS Anywhere is a new feature that gives customers the ability to run containers on their own hardware in their own data centers with the same powerful simplicity they get from the ECS running in the AWS cloud. Customers won't need to install or operate their own container orchestration software on premises anymore and can use the cloud-based, fully managed, and highly scalable ECS container orchestration service to manage on-premises containers. Your teams can use consistent tooling and APIs for all of their containers-based applications on-prem or at AWS, which makes it easy to manage clusters, schedule workloads, and monitor your applications wherever they are running. So it doesn't matter if they are on-premise or they are in AWS. You will still get the same experience as if you are running them within AWS Cloud. Similarly, one more thing, the same use case, if you want to run it on-premise or other clouds, you can use EKS Anywhere and EKS Distro. So again, this is in preview too. Right now, it's available for you in preview. You can go and try and see how it works out for your company. So let me talk a bit about what EKS can do for you. EKS Anywhere can do for you. Amazon EKS Anywhere provides AWS-supported, simplified Kubernetes cluster installation and operations on premises. Amazon EKS Anywhere is an installable software package that creates clusters for operating Kubernetes on premises and the tooling to provide full cluster lifecycle support. Amazon EKS Anywhere also uses the EKS distro, the same Kubernetes distribution deployed by Amazon EKS, allowing customers to easily create clusters consistent with Amazon EKS best practices. Now, customers can eliminate the fragmented collection of vendor support agreements and tools required to install and operate Kubernetes clusters, irrespective of where their applications needs to be deployed. As I said, on-premise, in the cloud, doesn't matter. You can use Amazon EKS Anywhere, and it should be able to take care of both your on-premise as well as in cloud. One more thing, there are additions to the new EKS dashboard right now. You could see add-ons. Now you can add add-ons. So we are very excited to announce that EKS now provides an integrated dashboard for observability into Kubernetes clusters across various deployment options, including on-premises. Cluster operators and applications developers can use EKS as a single place to organize, visualize, and troubleshoot their Kubernetes applications running on Amazon EKS. The EKS dashboard is hosted in the AWS console and is available automatically for all EKS clusters. And the new feature to support common operation software, which extends the operation functionality of Kubernetes. As I said, it's basically the add-ons we are talking about. You can now use EKS to keep this software up to date with new EKS add-ons. So as I said, this is all under preview. Feel free to go and try them. And when we make an announcement, we already have a lot of partners who are already working with us to make the preview go live and make it general availability for the public. So this was a bit of a refresher on the container technologies and the container options that are available on AWS. With this, I will hand it over to Clinton for talking about what we are going to achieve with Snyk and also do a demo on how we are going to do a live hack of the containers. Thank you.
All right, thank you very much, Raj. Let me share my screen here. If you could just go ahead and cancel out. My name is Clinton. I'm a principal solution engineer at Snyk. If you're unfamiliar, our name is actually an acronym. It stands for So Now You Know. So now you know. I've been with Snyk about 1.5 years now, and before that, I was a DevOps engineer, cloud architect, very familiar with AWS, and very excited about all of the container and Kubernetes technologies that Rob was just mentioning. Here at Snyk, our mission is to help organizations, but particularly development teams in organizations, develop fast and stay secure. And what that really involves is a suite or a platform of security technologies targeted at the developer to help secure every aspect of the modern or cloud-native software supply chain. Snyk is a very active AWS partner. We are an advanced technology partner within the AWS partner network. And that means we've been technically validated to work seamlessly with AWS services. We have an AWS DevOps competency and 2 service-ready designations for AWS Lambda and Amazon Linux 2. We are also a private offer-enabled seller in the AWS Marketplace, which means customers can use their existing AWS billing mechanisms to purchase our Snyk software while also using your committed spend within AWS, which is sometimes called the EDP or Enterprise Discount Program. We have a number of AWS Quick Starts available as well, which allow you to build automated deployments to really get your hands on with Snyk technology quickly and integrate with your other AWS services. So I'll circle back toward the end of the presentation today to talk more about our marketplace offerings, what you can find in terms of AWS Quick Starts for Snyk. But if you remember one thing from this slide, it's really that 2.8 million developers using Snyk. We're very proud of that number. That actually represents about 10% of all software developers on the planet at this moment. And that's because developers and software engineers realize that there's a gap between a lot of the existing security tooling on the market and the new, what we call the cloud native software supply chain, which is really recognizing that applications are built differently today than they would have been, 10 years ago or even 5 years ago, where you see less reliance on sort of first-party proprietary code, everything built in-house, less reliance on hardware infrastructure, for example, and much more reliance on things like infrastructure as code, on containers, on Kubernetes, on cloud services. But increasingly, it's the developers who are responsible for defining all of these services. The whole idea of infrastructure as code, meaning the supporting infrastructure for the application actually lives in the Git repository along with the application code and things like the open source dependency tree, maybe the Docker file that builds the container. What that means is that traditional application security tools don't really apply, and they can't really function well to enable developers to remediate, right? Which is ultimately what we want. So where Snyk comes in is the ability to secure the overall, this app service framework or cloud native software security stack. The way we do that is by looking at the 4 aspects of what we consider to be the new software supply chain. You're always going to have custom code, right, which is that little bit of iceberg above the waterline here, which is the proprietary code of my application, right? But that's now a lot smaller than it used to be, as opposed to, again, several years ago where that was the majority of the application. Now only 10 to 20% of your code base is going to be proprietary. The vast majority of it is going to come from things like open source code. So the libraries, the dependencies that allow that application to run is where 80 to 90% of your code base is now going to come from. But that also means that 80 to 90% of your vulnerabilities are going to come from those open source libraries. And it's the developers who are choosing those frameworks that allows their application to run without a lot of visibility into that entire dependency tree. There's obviously a security problem here. Containers almost complicate that problem more, right? Because now developers are not only choosing the open source libraries associated with the application, but also all of the Linux packages that are now supporting this new unit of delivery. So it's packaged together. The operating system is included when you're delivering an application as a container image. That obviously creates a lot of scale. You can build and deploy containers in a matter of seconds, push them into ECR, for example, into EKS, onto a Kubernetes cluster, which we're going to see in just a second here. It's extremely rapid to utilize container-based development. However, that comes with some additional security risk, because all of those hundreds of Linux packages that are coming from public sources, the developer doesn't necessarily have a lot of visibility into them. I can't see from my Docker file, for example, what packages are being brought in by the parent image that I'm utilizing to build my container. So again, what's needed is a new security approach that allows a developer to get that visibility to make better decisions about what's going into their container. And then the final layer is infrastructure as code, as I mentioned, which again is a responsibility that's falling onto the developer much more so than in the past, where the cloud infrastructure is being defined in YAML files, essentially, sitting in the repository alongside the rest of the application. But this comes with a lot of security risk because those infrastructure as code frameworks may not have secure defaults. And certainly an application developer is not going to be an expert in all the different kinds of cloud infrastructure they might want to spin up. So infrastructure as code has recently been called by the NSA here in the United States as the #1 cloud vulnerability, is misconfiguration coming from IAC. So taken together, this new software supply chain introduces a lot of risk, but ultimately it all falls on the developer to remediate because all of this code is now living together in the same repository. So what can be done here? Well, this is how and why we built out the Snyk platform to address all 4 of these aspects of the new software supply chain: open source code, containers, infrastructure as code, and finally, custom code. So we got our start with open source, recognizing that this 80 to 90% of code that now makes up the new application needs a new kind of security solution to actually resolve that entire dependency tree, identify issues, but most importantly, give the developer remediation advice when it matters, which is in their workflow as they're building the application. We then moved on to a container security solution, which is what we're going to be looking at today. The ability to look at those Linux packages, the dependencies inside the container image, determine what vulnerabilities exist, and then give the developer actionable advice, which is really important. The third piece, of course, infrastructure as code, a solution that scans those IAC files. So your Kubernetes manifests that are configuring those containers to run out into a cluster. The Terraform and eventually things like CloudFormation that will define that cloud infrastructure from code and actually spin it up in a production environment. So these 4 products constitute the Snyk platform for developer-first cloud-native application security. Across all 4, we're looking to, again, empower developers. That means to get scale, to get adoption from a security tool, it really needs to be frictionless. It needs to meet development teams where they're already at, using the tools they're already using, integrating directly into their workflows on the command line, in the IDE, inside their CI/CD pipeline, integrated directly with their AWS services so that they can embrace security, implement it early without impacting the velocity that is now the incentive for most development teams, right? DevOps means deploying every few minutes rather than every few months. What we need are security solutions that can keep up with that. That means integrating into the developer environment. The second piece, though, is it's not enough to just identify vulnerabilities. We can't just generate a big PDF like those traditional security tools, dump that onto a developer and say, now figure out what to do. You have to automate the fix, and that means identifying the action that a developer can take to actually remediate the problems that we're finding. So we'll look at some examples of that today as we're doing this container live hack of how we can immediately show the developer improvements they can make across their application stack. And the third piece of everything we do here at Snyk is security depth. And that means that we leverage the most timely, up-to-date, and accurate vulnerability data across these products, our open source container infrastructure and our custom code or static analysis tool. Because you can't rely solely on public sources. You need to curate vulnerability data, ensure you're eliminating as much as possible the duplicates and false positives and noise that tend to plague a lot of traditional security solutions. And you're augmenting with the right kind of data and analysis to allow developers to prioritize their remediation, to look at what vulnerabilities are actually exploitable from the outside, to look at which ones are reachable in the context of your application, to combine signals from my container and my infrastructure and the other parts of my application to determine what the blast radius is of particular vulnerabilities. That's how we can really enable intelligent prioritization that ultimately gets at the quickest and best possible remediation. So what does the sort of DevSecOps pipeline look like? And this diagram, for anybody who's been in the industry a while, used to be kind of a straight line, right? It would start with code and eventually make its way into production. And in between, there'd be this big, scary security gate, right? That's really fundamentally changed with DevOps, which is now much more of an infinite loop, right? You're constantly deploying, constantly writing code, merging things into a mainline branch, scanning them, testing them with automated tools, going into production multiple times a day. And our Snyk services can integrate across this sort of infinite loop to provide value to the developer at every stop along the way. So for example, our Snyk open source tool, which looks at, again, vulnerabilities in the open source dependency tree of the application, integrates across the AWS tool set. So we have support for AWS code build and code pipeline to automatically and continuously find and fix application vulnerabilities in those code repositories, as well as your serverless Lambda functions, for example. Snyk Container empowers those same developers to find and fix vulnerabilities in container images while accelerating delivery of cloud-native applications. So we can look at those vulnerabilities in the container registry, for example, inside ECR. We'll take a look at that today. We can monitor Amazon EKS clusters for new vulnerabilities, as well as misconfigurations in the cluster itself that can protect that application after deployment. And then finally, our Snyk infrastructure as code solution helps developers find and fix issues in things like Terraform and Kubernetes files with CloudFormation support on our roadmap as well. So if you're interested in purchasing any of these Snyk solutions, again, they're available in the AWS Marketplace. And I'll circle back at the end of our presentation to talk about the options there, as well as the quick starts that are available so you can start immediately seeing value from the Snyk platform on AWS. So I'm going to take a break from the slides for now, right? I think we're all at that point in the webinar where you really just want to get down to some brass tacks here. So what I'm going to do is show a live hack of a containerized application, which shows how easy it is to introduce vulnerable code into this kind of workflow, but also how easy it is to combine Snyk security intelligence and tooling with the ease of use of AWS services to easily find and remediate those vulnerabilities. So let me escape out of here. I'm going to be using a repository today called Goof. This is a sample application that we've developed here at Snyk. It is a to-do list application that uses Node.js with some very common technologies under the hood. It's a web application that can be easily deployed into a containerized environment. However, it's got some known vulnerabilities associated with it, which we're going to take a look at, as you can see here. And then we'll show how easy it is to actually remediate that. Now, I'm going to be deploying this onto AWS. And as Raj mentioned earlier, the AWS sort of container technologies give you a number of choices in terms of how you want to deploy. I'm going to be choosing the EKS option that Rob mentioned because I have a Kubernetes deployment already set to go in this repository, so I'll be able to easily push that into EKS. And my container images themselves are going to live in ECR, the Amazon Elastic Container Registry. So I've got my container images here. They're sitting in my Snyk demo repository in ECR. I also have my my EKS cluster already up and running. I wanted to save some time, so I've got that already set to go. That was actually a really easy process because on the command line, I simply ran the command EKS CTL or EKS cuddle. And if I look at the command I ran here, let's look at my history. What you'll see here is I've got this EKS CTL cluster create command that spun up the sort of entire EKS cluster, the nodes sitting underneath, all of the IAM roles, even the SSH key and everything I needed. So I have a cluster from zero that will run my application in AWS. So again, great work that Raj and the team at AWS have been doing to make this really a turnkey solution for a developer like me to spin up a cluster instantly with a single command. So if I now look at the Git repository, so I've checked out this Goof repo, right, and I've got this sitting here in my application. This actually involves two services. I've got a front-end service and a back-end service. And so the ability to, again, easily build those with Docker files and push those into the ECR registry couldn't be easier. So what I'll do here is actually run a Docker build. And I will tag this and actually have my my ECR URL already set up as an environment variable here. I'll say tag it with my, my ECR repository name, and I'm going to call this AWS webinar goof. And then I'm going to say build the current context, right? So this will take the Docker file. This is going to take essentially everything in my, my current context, build a container image. As you can see already, because it's a live demo, we've got an issue here. So I've got to probably encapsulate this in some curly braces, because my bash foo is not that great. All right, so that's not happening. Let me actually find that URL. So I'll just run a Docker image ls and grab it here. So try to make things easier for myself. That failed. That is the curse of the live demo. Now, let's go back to our Docker build command. I'm going to insert my URL that I just copied. And so we're going to tag this image with my ECR repository. We'll call it Snyk demo AWS webinar goof. As you can see, we've got that instantly built. I can now simply go ahead and push that into my, my ECR registry. So I'll just say Docker push, the same tag, and bam, layer already exists. So not a lot of additional work to do there. I'm going to do the same thing on this, this backend image. And again, feel free to follow along. We can post the URL in the chat even. GitHub.com/snyk/goof should have all of this material if you wanted to conduct this kind of live hack yourself. Okay, so I am going to tag this one as goof image. Whoops, I actually need to run the build first. Build and tag. Right, so we've got our second image built, and then I'm going to simply push this into, again, my ECR registry. All right, got everything up and running. If I then verify that over here in ECR, I've got my, my latest pushes here of both of those images into the registry. Now, I want to go ahead and deploy this application out into EKS. I've already got some manifests, so some Kubernetes deployment files that actually define how those two container images are going to interact with each other, the resources they need, the networking, all of the tagging, et cetera, that defines how that workload's going to run in the cluster. If I go to my manifest here, you see I've got a deployment and a service. And if I look at the deployment file, you'll actually see a number of, this is a pretty standard Kubernetes deployment, right? I'm defining, here's that same image, right, from my ECR registry. I'm going to say image pull policy always, so that we'll always have the most up-to-date version. And then we're simply tagging it, we're exposing a port, and we're sending this off into EKS. So that is simply a matter, because I've already run that EKSCTL command. It's actually got all of my my local kubectl configuration and context already set up. So all I have to do is run kubectl apply -f and then give it the folder with these manifests, right? So that's going to again look at those files, the deployments, and the services. They're unchanged because I had already deployed this earlier. And now my application's up and running in EKS with just those couple of commands. If I then load this URL, I've got my to-do list here ready to go. Webinar on Snyk and AWS. Let's just make sure it works. So just continue webinar, because that is my next to-do list item. Boom, right? I have an up and running to-do. We're done, right? Great webinar. We can give you a half an hour back in your day. Not quite yet, unfortunately, because again, I mentioned this is a very vulnerable application that we just deployed. Part of the reason it's vulnerable is this contains a package called Image Magic, and there was a very well-publicized vulnerability a few years ago. It was actually called Image Tragic, which allowed an attacker, someone from the outside, to exploit a certain kind of image that could then make arbitrary writes on the file system of either the server or the container that it's running on. This image, this container contains that vulnerable version of Image Magic. And actually, this is all spelled out. You can see the exploits in this Git repository as well. So let's actually try to now exploit, to hack that container that we just deployed. What I'm going to do, first of all, is run a command that shows me a directory listing on the container. And to do that, I'm going to run kubectl exec, because I want to execute a command on the container. And then I'm going to find the ID of the pod. So I'm just going to say kubectl get pod and give it the labels, right? So my app is goof and the tier is front end. And then I want the name of the pod. And then I'm going to run the ls command, right? Which should be as simple as there. This is the root file system of the container I just deployed. Here's what I'm going to do now. If I actually look at, again, in this goof repository, I've got an example image file that can actually be used to exploit this bug or this vulnerability in the container. It's called rce1.jpg, right? Now, I know what you're going to say. You can't cat a JPEG on the command line, right? But if we look at what's in this file, it's not an image. This is actually a crafted text file that's designed to exploit this vulnerability in ImageMagick. And here's the important part here. You can see this touch command, right? It's actually going to create a file called RCE1. It's going to make an arbitrary write to the file system. Now, here's what we're going to do. Is I'm going to say curl, right? I'm going to give it this file, and we're actually going to put this into a file field called Twitter picture, right? Because again, this is a kind of example app designed to show off this exploit. And I'm going to give it the local file that we just saw, image app, exploits, rce1.jpg, if I can type correctly today. And I'm then going to give it the URL of the application as it's sitting on EKS. Now, I think I've got this environment variable set up. I've got goof, image, LB for load balancer. I just pulled this out of the kubectl service that got set up, and I'm running that on port 3112. I'm then going to say /upload. So this is just me mimicking what it would be to upload this image through the web interface of the application. Oh, and again, I have got, let's see, what am I doing wrong here? Illegally formatted input field. Let's see, did I not terminate it? No, I terminated it. Let's see here. Oh, I didn't have the equals. That's what I didn't do, right? Live demos, ladies and gentlemen. Okay, here's the equals. Now, you can see we've got a pretty innocuous result. My application has said, found redirecting. So it's uploaded this image. My web app thinks everything is fine. However, let's remember that ls command we ran, and I'm going to run that again. So we are now looking at the file listing of this container. Oh, whoops! Actually, it's not in here because this is already the fixed version that I'm looking at here. Let me actually see if I can do this live here. If I look at that Docker file again. Image app, nano Docker file. Okay, I've got the vulnerable version there. Gonna get out of that. Let me then rebuild this one more time and push it back into ECR so that we can see the vulnerability. But essentially what would happen here is we would see that file, that RCE1, in the root of the container file system, right? So we've successfully exploited the vulnerability in this kubectl image. Let me see if I can build that here one more time. AWS webinar goof image. I might have just messed up the way I tagged it here. Let me build that one more time, make sure it is the right image we were looking at. Yep, node wheezy. Okay, and then I'm going to push this, and we'll just rerun this deployment. Okay, tag. All right, Docker push. Oh, I think I know what I did wrong. I didn't actually start this container after I added the vulnerable version. So let's actually do that here. So I'm going to run kubectl scale deployment goof image replicas equals 0. Okay, so that's going to scale it back down. If I then look at my kubectl get all right, so I'm not running any instances of that goof image container. Now, if I then say replicas equals 1, that's going to create a new container. Again, this is all the magic of Kubernetes, right? It's sending these commands to EKS. It's shifting my my containers around. I now should have a new version of this pod already running. See, 1 to 1, it's running. It's been up for 14 seconds, right? So think I fixed my problem now. If we then rerun this curl command one more time, this is going to, again, activate that the vulnerability in ImageMagick. Because now what is this saying? Failed to open local up because I'm in the wrong folder. Okay, got our redirect here. Now I simply want to look at the file system one more time. So I'm going to go back up to the kubectl command where we're in the ls. And then finally, if the demo gods are smiling on me, they're not today, we'll just pretend that I've actually got the exploiter file here. Shifting gears here. So we've proven, if you'll nudge, nudge, wink, wink along with me, that we can exploit a vulnerability remotely in this container running on ECS. Now, what can I actually do about that? Well, this is where Snyk comes in. So what I'm going to say is I've got this container built. I can run Snyk container test and then give it the name of the image that, that we actually want to test. So if I then, let me run docker image ls here. I can say this image here that we built, right, which is the Snyk demo AWS webinar goof image. So we'll copy that. I'll say Snyk container test, the name of the image. And then I'm also going to give it the Docker file that we used to build it. That was actually this one in here, image app. What this is going to do is analyze my container dependencies in that image. It's going to determine the base image that I'm using, find all of the vulnerabilities in the image, and then Snyk is going to give me a set of remediation options. It's actually going to show me. So if I look here, I've actually got a number of vulnerabilities found, right? So in here is going to include that, that ImageMagick vulnerability that we just exploited. These are sorted by severity. We can also identify which vulnerabilities came from my base image, as well as the fixed version for each one. Now this is an older image here that that I've been utilizing, right? This is Debbie and Wheezy. This is kind of several years old. If I then make a small modification to actually update that to an image that's at least maintained. Let me pull up nano image app Docker file, and we'll actually use node 6 here. So I'll save that. I'll quickly rebuild that one more time, which should be pretty fast. Okay, so we're going to rebuild, which I think was the right one. Yep. Oh, actually, sorry. There we go. Okay, so everything's rebuilt with that newer version of Node 6. I am then going to run Snyk container test on this image, give it the URL of the Docker file. And what we're going to get now is a result containing base image remediation upgrade advice. So we'll actually be able to know a more secure base image that I can utilize within this container because I've run the Snyk container test command on it. One of the benefits to Snyk is that you can actually deploy our tooling essentially anywhere. You can integrate directly with a Git repository. We can scan not only Docker files, but also open source vulnerabilities inside the application. We can scan infrastructure vulnerabilities and also our first-party static code testing. We can do it via command line, as I'm doing here. You can also easily drop Snyk into a CI/CD pipeline or something, some kind of automated tooling to ensure that you're blocking deployments based on the presence of vulnerabilities. So here's the remediation advice for this container. I've got 900 vulnerabilities in this Node 6 image. 230 of them are high. We are going to recommend alternate parent images I can use that would drastically reduce my vulnerability count on this container, including if I went to node 14 Debian Buster Slim in this situation, I can actually reduce that high vulnerability count from 230 down to just 12, right? So just by running a single command using Snyk, in this case, in my developer workflow, I can drastically reduce the vulnerability count with this remediation advice. We can also point out when vulnerabilities are coming in from other user layer. So these vulnerabilities will indicate came from my container base image. However, if I introduced a package in my Docker file where I'm including a parent package that has a vulnerable dependency, we'll identify that here as well. So I can actually know exactly where to look as a developer, get not only the line in my Docker file that introduced the vulnerability, and then also get the fix advice. So I'll actually tell you where the issues were remediated, so you can actually determine the package you need to upgrade to, or if they come from the base image, we'll give you options so that you can choose a more secure base to start with. So that's really the quick overview of Snyk Container, specifically on the command line within the developer context. But again, we have a number of other integrations as well. You'll recall that I pushed these images into Amazon ECR. We can actually look at vulnerabilities inside the container registry itself. So if I go to integrations, I'm here in my Snyk dashboard now. I can integrate Snyk directly with ECR. So I've got this configured already. I simply say I want to onboard these images, and I want to look at the two that we just pushed in, this webinar goof and webinar goof image. I'm going to add those repositories. Snyk is now going to scan those images directly in the registry. And one of the benefits to doing this is we can rescan on a daily basis. So if there's new vulnerabilities in those images tomorrow or in 6 months, you can get a notification based on that. So if I now look at my images sitting here in ECR and I dive into the one we were just looking at, I'm going to see those same vulnerabilities. But I'm also going to see that remediation advice. Snyk is going to tell me not only do I have these vulnerabilities in my node image, but here are some other versions I might want to consider updating to, including the one we saw on the command line, the node 14 buster slim, to drastically reduce my my vulnerability count. So again, lots of ways to integrate Snyk, whether it's in the container registry. We can also monitor your workloads on EKS directly. So I could have run a Snyk monitor service integrated directly with my EKS cluster, gotten the same information. But again, we're bringing it back to the developer by not only saying, here are the vulnerabilities you've introduced, but here's what you can do about it, right? We'll actually show where things got introduced, the full introduction path of each vulnerability. We'll indicate the exploit maturity, so I can know if there's actually publicly posted code that can be used to exploit this from the outside. We'll prioritize everything according to our Snyk priority score, which gives you a really high fidelity view of what vulnerabilities should be remediated first. And then again, everything is going to be brought back to what guidance or what advice can we give the developer to make better decisions about what's going into their container image. We have a number of other, I mentioned earlier, we have actually 4 products in the Snyk platform. So it's not just container security. We can also look at vulnerabilities in open source libraries in the application. So if I look at this Git repository that we had referred to earlier, we not only see vulnerabilities from my Docker file, right? So those container issues we were looking at, I also have vulnerabilities inside my my open source dependency tree, inside my package.json file here. I've got issues within the deployment YAML file that we looked at earlier on the command line. So I've got misconfigurations associated with with how I'm actually deploying it. And then finally, I've got first-party code issues. So this is Snyk Code, which is our static analysis tool. If I look at each of these in turn, these are vulnerabilities coming in through my open source dependency tree. Again, we identify the remediation, which is the upgrade the developer can make, and we make it fully automated. So I can just click to fix this vulnerability, introduce a new pull request. On the infrastructure as code side, I've got some misconfigurations. Remember we looked at that file, we weren't setting CPU and memory limits on the deployment. We're detecting this, or Snyk is detecting it, just by looking at that YAML file as it sits in a Git repository. So again, a great way to look at security issues in the developer workflow where remediating them is sort of as quick and cheap as possible. And then we give the remediation advice directly in line. In this case, I have to add resources.limits.memory to my YAML file here. So that's a really quick introduction to the overall Snyk platform. But if you remember anything, it's those 3 points we talked about earlier. Developer first, integrating across the SDLC within that DevSecOps infinite loop, whether it's in the registry, in the cluster, on the command line, in the pipeline, in the IDE. We're always going to give, wherever we can, remediation advice to the developer because we care about fixes and not problems. And we're going to have unmatched security depth when it comes to detecting vulnerabilities, eliminating noise, and eliminating those false positives. So that'll do it for the demo for today. I am going to bring it back to just a couple more slides to talk more about our AWS partnership and the ways that you can consume Snyk on the AWS platform. So we talked about, again, the integration points here. There are also AWS Quick Starts available. We have 3 currently with, I think, 1 more additional that should be coming very soon. You can deploy Snyk to secure your Lambda functions, which would be the serverless CI/CD Quick Start. We have a Snyk controller, which is the Amazon EKS integration that you can deploy directly into an EKS cluster, get that vulnerability information about the container images running in your live workloads. And then we have a generic Snyk security quick start as well. So again, integrated across a variety of AWS services, very easy ways to start getting value from Snyk immediately by utilizing the quick starts. And then the last thing to mention is the AWS Marketplace Integration. This is something we're very excited about this week. This means that Snyk is available now for enterprise customers through the EDP program that I mentioned earlier, so the Enterprise Discount Program. You can now purchase Snyk directly through the AWS Marketplace and use your committed spend with AWS to purchase Snyk to get the security value out of the Snyk platform. We also have private offer capability so that you can negotiate private terms and pricing directly with a Snyk representative. We'll build a private offer in the marketplace in a matter of days, provide you a unique URL for your dedicated listing so that you can get exactly the security coverage that you're looking for out of Snyk, all within the marketplace, all using the same billing and cost management service tools you use for all of your other AWS services. So I think with that, that's about all I have for today, but I did want to throw it back over to Sharon, who I believe is going to address some of the Q&A.
Sure am. Thank you so much, Raj and Clinton. That was really awesome. All right. And Clinton, I went ahead and put the link to that repo that you were working in the chat there. So if people wanted to follow along, hopefully they were able to do so. Yeah, so Q&A. All right. So let's see. First here, we've got a question that asks, does application dependencies identified part of package.json, or can it also look at raw files like .jar files?
Yeah, that's a great question. So primarily, Snyk utilizes the package manager to look at the source of truth for those dependencies. We do also have some capacity to look at open source dependencies inside jar files, for example. So the answer is it really depends on your ecosystem and what your build process is for generating those artifacts. I will also point out that we recently announced an acquisition this week of a company called FosID that focuses on binary scanning. And so we're going to have some big announcements coming soon about extending our Snyk platform coverage beyond what we've traditionally done with package managers directly into identifying open source components inside the binary. So really interesting stuff coming there soon as well.
Very cool. All right. Let's see. Next, do you have a way to inject Snyk results into the developer flow? For instance, can you show like badges on GitHub that there were findings in a PR?
It's another great question. I'm actually going to share my screen one more time here to show that, because I canceled out of it. Yes, the answer is absolutely, and that is primarily the way developers, I think, want to consume not just Snyk but other tools as well. Is they say, I want this to be in my workflow. I don't want to have to go over to another dashboard or another pane of glass, for example, to look at my my security data or anything else. If I actually go into GitHub and I look at my fork of that goof repo that we were looking at earlier, what you can see is there was a PR that I put in here that actually added new vulnerabilities, right? So this is me as a developer going in and saying, I want to add some commits, and in this case, I put in some open source packages that that are new, that have new vulnerabilities associated with them. But you can see this PR is still open. It didn't get merged. That's because Snyk actually failed the pull request check. We actually said we're looking at new vulnerabilities coming into this repo. We're going to fail that because of the presence of vulnerabilities in this delta, and that's why this PR wasn't merged in. So that's a really common way to do security scanning early in the process, to do it inside the developer workflow, sort of where they're already living, and to not require that friction, right? That takes a developer out of their context into something else. So they want to live in their IDE inside GitHub or inside their source control manager. That's where it makes sense to provide that data as seamlessly as possible.
Okay. I think we have time for a couple more.
Sure.
Can Snyk detect tainted cryptographic keys in CI/CD pipelines?
That's a great question. So we do have some checks within our Snyk IAC to look for things like hard-coded secrets, for example. So if they're common misconfigurations that we can identify, then the answer is yes. We're actually rapidly expanding our coverage of the Snyk infrastructure as code, so we can be able to detect things like that. But again, keep in mind, one of the advantages of Snyk is that because we're scanning early, we can actually look at those potential misconfigurations and vulnerabilities before they're actually deployed, right? So we can do a scan of those YAML files directly or JSON files you're using for configuration, essentially statically, as they're in the Git repository, as they're on the local command line, and before they even make their way into a pipeline. Ideally, you want to detect that as early as possible, close that remediation loop before that pipeline's even initiated.
Yeah. So following on from that, how is Snyk's vulnerability database updated? Is it internal researchers or a third-party source, or?
Yeah, it's our internal security research team that's updating that. So we do consult with public sources like the NVD, for example. What we don't do is what a lot of other security companies will do, is just go out and script that and pull everything in, right? You get a lot of noise that way, a lot of false positives, duplicates, things like that. We actually will hand curate those vulnerabilities before they move into our vulnerability database. We update that on a daily basis. So if there's a new vulnerability, you'll get notified immediately as soon as it's added, if it's detected in one of your workloads. And then we're always augmenting that with those additional sources that I mentioned. So things like the exploit maturity, you wouldn't necessarily see identified in a public source. The reachability analysis, and that's that prioritization, the combining all of that into what should my remediation priority be for these specific issues in the context of this specific application. So, really proud of the work that our R&D team has done, not only in creating the most reliable vulnerability database, but then augmenting it with the data that developers actually need in order to remediate.
Okay. All right, I think we've got time for one more. So I'm going to ask this one. Can you share some Kubernetes vulnerabilities that Snyk has identified?
Yeah, great question. We have a number of security rules in our infrastructure as code database, so we can look for things like we saw looking at that deployment YAML, things like not having your resource constraints set on a particular workload, things like containers that are running as root that don't have a non-root user run, hard-coded IP addresses was another big one that was identified as a potential vulnerability source. We were able to add that rule to our infrastructure as code within a number of hours of that vulnerability being discovered, and then alert everyone who had a hard-coded IP in Kubernetes deployments that were being tracked by Snyk. So that is constantly expanding. We're always adding rules to that IAC data set. That's actually public and information now. You can look through those rules. And what we're expanding into is the ability to actually custom define, to use something like the Open Policy Agent and Rego files to create rules specifically for your group of applications, so that Snyk is combining best practices across the industry along with what you specifically care about in deploying your own workloads.
Excellent. All right. Well, that's about all the time we have today for questions, folks. If you did submit a question and we did not address it here in the live Q&A, rest assured we are going to send all these questions over to Clinton and Raj, and they will follow up with you afterwards. And just to remind you that this session has been recorded, so if you missed any or all of it, you just want to go back and watch it again, you are absolutely welcome to do so. We'll be sending an email afterwards with instructions for how to access the webinar on demand. You can also visit us at securityboulevard.com/webinars, and this webinar and others will be there for you. All right, so the moment you've all been waiting for, we are going to do our drawing for the 4 Amazon gift cards. And our first winner today is Decio C. I hope I'm pronouncing that correctly. Congratulations. Next, we've got Bill T. Congratulations, Bill. Salvatore P. Congratulations. And finally, Martina R. Congratulations to all our Amazon winners. All right, folks, for our Amazon winners, we'll be sending an email to you with instructions for how to claim your gift card. If you don't see that within a few hours, make sure to check your spam folder, please. And thank you so much to the audience and to Raj and Clinton for their time today. Thanks for spending an hour with us here. We hope to see you again at another Security Boulevard webinar.
Thank you very much.
Yeah, absolutely. I'm Sharon Florentine, signing off.